Okay, so good day to our grade 8 90 Science High School students. So this is going to be our last lesson for geometry. It's on trigonometric functions on the unit circle. Okay, so suppose that we have x and y as our coordinates on our circle here. Okay, and the general formula for finding the equation of a circle is of course given by x squared plus y squared is equal to r squared, where theta is an angle in a standard position with terminal side OP. So this is the side where theta ends, as shown at the right. So we define sine of theta and cosine of theta as the ratio between y and the radius. Do you remember that problem, guys? So we know that sine is equal to opposite over the hypotenuse for the trigonometric ratios. So let's say, for example, that this is your angle. So that means the opposite over the hypotenuse, or y all over r, will be the value of sine theta, and of course cosine theta would be adjacent over hypotenuse, or x all over r. The circle x squared plus y squared is equal to 1 is called the unit circle. So since it has a value of 1 for the radius, so 1 here, 1 here, negative 1 here, and negative 1 here on our unit circle. That's why it's called a unit circle. The circle is the easiest one to work with because sine theta and cosine theta are simply the y and x coordinates of the points where the terminal side of theta intersects the circle. Okay, angles in standard position whose measures are multiples of 30 or pi over 6 radians or multiples of 45 degrees or pi over 4 radians are called familiar angles. Okay, so they are the most basic angles that we have for solving problems in terms of the unit circle. To obtain the trigonometric values of sine, cosine, and tangents for the familiar angles, so we have to use the 30, 60, 90 ratio or the 45, 45, 90 ratio. Angles in the standard position are multiples of 30 or pi over 6 radians or multiples of 45 degrees or pi over 4 radians. Okay, so as we can see here, so for sine 30, we have a value, an opposite value of 1 and an adjacent value of square root of 3. So therefore, we get that sine 30 is equal to 1/2 if the radius is equal to 2. Okay, goes the same with cosine of 30. Okay, so we have here our opposite value, our adjacent value, which is square root of 3, divided by the radius 2, so that's square root of 3 all over 2. For the sine of 45, this is very familiar with you guys, especially in the 45, 45, 90 triangle ratio. So we still maintain the same values. And if you try to see a pattern here, try to look for a pattern. So for sine 60, so that's going to be y all over r, which is square root of 3 all over 2. And for cosine of 30, so that's x all over r, that's equal to 1/2. Okay. So these are the familiar angles in our coordinate plane. We have the 30 degrees, the 150 degrees, 210, 330 degrees. And these are the values for the 30 angles. Okay, so we have here, if you're going to try to look for a pattern, this is the value of x and this is the value of y. We have the square root of 3 all over 2 and then 1/2, and then the sign just changes. This negative, positive, negative, negative, and then positive, negative. And their values also change. Okay, their values also change depending on their location on the xy coordinate plane and to which quadrant they belong to. So for quadrant 1, all positives. For quadrant 2, negative and positive. Quadrant 3, negative and negative. For quadrant 4, positive and negative values. Okay, and for the values, for the reference angles with the values 60, 120, 240, and 300, we have the radians pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 respectively. So it's an increasing increment of 1 pi per turn on the unit circle. And still the same pattern emerges from the unit circle or the coordinate plane that we have. We have positive, negative, negative, positive, negative, negative, and positive, negative for quadrants 1, 2, 3, and 4 respectively. And if you try to look at the pattern, for the 30 pattern, the square root of 3 over 2 comes first, or that's the x or our cosine value. And then for the 60 pattern, our cosine or our x value is 1/2. So they just get interchange. Okay, so for 30, the first part is the square root of 3 over 2, and you just put positive negatives. And then for the 60 values, so that's 1/2 first, then square root of 3 all over 2. The 45 reference angle are super much easier to remember because they're just square root of 2 all over 2 on all parts of the quadrants, from the 4 quadrants of our unit circle. So that's square root of 2 all over 2 and square root of 2 all over 2 for the quadrant 1. Okay, then the negative positive for the quadrant 2, the negative value for the 3rd quadrant, and the positive negative value for the 4th quadrant. And their angle values are just 45, 135, 225, and 350. So they're very easy to memorize, especially for the 45 degree values. And these values determine the sine, cosine, and then the tangent values of our circles and also of our triangles inscribed in the unit circle. So trigonometry, the heart of trigonometry lies on finding the relationships between the sides and the angles of these triangles inscribed in the unit circle. So as you can see here, so we can derive patterns. Patterns emerge from the regularities or the quadrants that we try to create on our trigonometric plane. Okay, and then lastly, we have the values for our main angles. 0 degrees, of course, so that's going to be 1, 0. Pi all over 2, so that's 180 degrees, which is equal to pi. 270 degrees, so that's 3 pi all over 2. Okay, and of course 360, so that's 0, 0 again. So the pattern just continues. And these are the angles that we find that we can derive based from those relationships. Okay, and that ends our lesson on unit circles. Let's try to practice more on our activities. That's the last lesson, and thank you for listening.